Hi, everybody. There is a term used in chemistry, and it's called being miscible. And it's an unusual word. We don't use this word in common English very often. But if two liquids are miscible, that means that they can be completely mixed together and form a stable solution so that one does not fall out or separate out through time. For example, water and alcohol are completely miscible. If you mix a mixed drink and stir it up, you get that complete mixture. In antifreeze, you get ethylene glycol and water. Those are 100% miscible. In a nice cup of coffee, all of the lovely esters and flavorings and water are 100% miscible. Now, we're not counting the grounds, but we are counting all of the other bits and pieces. The flavorings that go into making apple juice and grape juice and things like that, those are 100% miscible. So some things are miscible. They can 100% dissolve in each other, and some things are immiscible. Immiscible are liquids that do not mix when you put them together. The classic example is oil and water. Vinegar and oil salad dressing, they just don't mix. And so we still try and mix them together, but you're always going to end up with layers. But there are a whole collection of things that we use in our everyday life that have a combination of both oil and water properties. And we like that combination. For example, your hair conditioner. It moisturizes your hair like an oil, but we rinse it out of our hair with water. So it has to be oily enough to bond with the hair, but watery enough to go down the drain, the residue, rinsed out with water. Hand lotion. We want it to moisturize like an oil and bond with our skin, but if it feels like lard and grease, we're not going to put it on our hand. Mayonnaise, it's made with a mixture of vinegar, which is very watery. It's matter of fact an acid, and cooking oil. So how do you make such a thing? That is definitely, if oil and water don't mix, how do you mix them to make products that we use every day? Well, what you're talking about making is something that is called an emulsion. An emulsion, by definition, is a mixture of two or more of the liquids that are not typically miscible. And these are part of the collection of solutions that are called colloids. Remember, our types of solutions are solutions, suspensions, and colloids. Well, in that broad group of colloids, one part of that collection of colloids are emulsions. And emulsions are made stable by adding an emulsifying agent or by aggressive mixing. And the nice thing about emulsions is they have the properties of both the oily and the watery compounds that make them up. They typically are opaque, they're thick, they're too thick usually to exhibit the Tyndall effect, but here's a whole collection of examples. Ice cream, hand cream, face cream, mayonnaise, a lot of those dairy products we love, butter, margarine, latex paint, most of the salad dressings that we're going to deal with in life, these are emulsions. Now, one of the ways you can make an emulsion is you have to have an emulsifying agent. An emulsifying agent is something that will act as a stabilizer, preventing the two immiscible compounds from separating. So how do they do this? If you add an emulsifying agent, also called an emulsifier, what it does is it encapsulates, it puts into a little capsule the other substance, and the little capsules that it creates are called micelles. And then those micelles are dispersed within the liquid. And we're going to talk more about this process in the next few minutes. So that's one way to create an emulsion is with an emulsifying agent. The other way to create an emulsion is by very aggressive mixing. In your kitchen, you may have a blender, and trying to make vinegar and oil salad dressing, in order to serve it, you have to shake the stink out of it. You shake it very aggressively. You may put it through a blender, get it very, very well mixed before you use it, because otherwise you're given the top pour is going to be all oil and the bottom is going to be all vinegar. And that's not why you make oil and vinegar salad dressing. Same thing happens if you are going to make ice cream. The faster you can aggressively mix these things, the better the emulsion is going to be. And that's why a blender and a commercial ice cream maker is going to give you a better emulsion than simply trying to do this by hand. Now, there are a variety of emulsifying agents that can be added, and one class of them are called surfactants. Now, the word surfactant stands for surface active agent. Now, surface active agents, surfactants, are molecules that have two different ends. They're very polar, very, very polar, and one end of them is referred to as hydrophilic. Hydrophilic meaning water-loving. The hydrophilic or water-loving end looks ionic, and it is great at bonding to water, and it is great at bonding to other ionic compounds. The other end of one of these emulsifying agents or surfactants is very covalent looking. It is hydrophobic, water hating, and it is wonderful at bonding to oil and grease. So these surfactants are the go-betweens. They are the go-betweens if you want to connect oil and water. Because oil and water will not mix, you have to have some sort of a go-between. So what is the best go-between out there? Well, the best go-between out there, the most common surfactant we have, is plain old ordinary soap. A plain old ordinary soap molecule has its hydrophilic, water-loving end, and this end that's very polar is going to be great at bonding with water. And then it's got its covalent looking hydrophobic end that's great at bonding with dirt and oil. So if you have greasy dishes and you're trying to do your dishes, you put soap, and soap is the superhero in the middle. And what it's going to do is it's going to bond with the water, it's going to bond with the oil and dirt, and as you wash your dishes, when you pull the plug on the sink, when the water goes down the tubes, it is going to, because it's bonded with the water and the molecules also bonded with the oil and dirt, it's going to take everything down the drain with it. It is the go-between. It is the thing that is going to be the link that will connect with both the water and the oil. Now, it doesn't just simply bond between the oil and the water. It actually surrounds the surrounds the grease, and it surrounds the grease by making something which is called a micelle. Now, a micelle is a three-dimensional structure, and each one of these little soap molecules has its water-loving end and its water-hating end. And there used to be an old Dawn dishwashing commercial that said, Dawn takes grease out of your way. Well, I like to refer back to that commercial because it's really what's happening with surfactants and with soap. So if this is a little particle of grease, grime, yuck, in your dishwater, here's what happens. Little soap molecules are going to connect with that grease and grime. This is the end that loves oil. This is the end that loves water, and it's going to connect with it. But it's not just going to connect one, it's going to connect gobs and gobs and gobs and gobs and gobs and gobs of them so that it is totally surrounded. It's going to be totally encapsulated. So encapsulated so that in the water, it is going to be totally, totally, totally surrounded on the outside. It's going to be water loving. And you're not going to even notice there's any grease there because it's hidden. It's buried in the middle of this micelle. If you've ever washed dishes after a large family function like Thanksgiving or Christmas or something like that, and you notice that your dishwater is kind of giving up the ghost and it's kind of greasy and yucky and doesn't work anymore, you have run out of soap. You need more soap. The reason you have run out of soap is because of the fact that every one of these little soap molecules is busy creating one of these little micelles. Then don't be a cheapskate, dump the water, get clean water, because you have to have these soap molecules in order to make the micelles, surround the grease, and take it out of your way. Whenever you want to create an emulsion, you have to encapsulate the smaller concentration material. And there are two basic kinds of emulsions. You can have oil in water emulsions and water in oil emulsions. An oil in water emulsion is one where you have a little bit of oil and it is surrounded by a lot of water. Now, this is going to be something that feels very watery to the touch. A lot of cheaper hair conditioners, dishwaters, things like that, these are going to be oil and water emulsions. It's going to dissolve in water very, very easily. But you can take those little things with the hydrophilic and hydrophobic ends, you could turn them around. You can put water in the middle, have a little bit of water in them, and you can have a water in oil emulsion, and you can create things that are thicker and creamier hand creams, deeper conditioners, and a lot of styling products and things like that. So it depends on which direction the little polar molecules face. Now, what do we use as emulsifying agents? Well, soaps and detergents all the time. They are great surfactants and emulsifying agents. People make their own mayonnaise, and if you're going to make your own mayonnaise, you have to have eggs. And the chemical in eggs that make mayonnaise are lecithin. Lecithin is the chemical in egg yolks that actually help bond the acid plus the oil to make the colloid, the emulsion, mayonnaise. Sodium phosphate, commonly used to make processed cheese, and people who are really good cooks who play with that molecular gastronomy, that is an emulsion that can be used. But the same sodium phosphate is also sold in hardware stores if you really, really, really want to clean a floor before you paint it, because of the fact that it's so good at dissolving oils and water if you really want to clean something well, which is kind of a weird combo that you can do that. And there are other organic salts that also are used as emulsifying agents. Last thing about emulsions, these are delicate balance of little suspended particles of typically an oil inside of a watery mixture. This is something, because it is this delicate balance, they are easily destroyed. You add heat, you add contamination by getting dirty fingers in there, or just plain time, and emulsions can be destroyed. So if you have mayonnaise, salad dressing, clam chowder, if it's been on the shelf for a long time and the package is never opened, that's not a problem. But once you open that package and you start messing around in there, apply some heat to it, leave some hand cream out, take butter and add some heat to it, put whipped cream on top of cocoa and add some heat to it, it will break down into its base components quite easily. And that is because this is a delicate balance, kind of tricky to create, and very easily falls apart. All right, thank you, folks. We'll see you next time. Bye-bye.